This is Dr. Rob Ward, and I'd like to welcome you to drrobwebinar.com. For the next several minutes, we're going to take a journey in understanding the science of redox biochemistry, which is essentially the science of healing. My background is as a family practitioner. I've been in clinical practice for over 30 years. I have backgrounds in functional medicine and addiction medicine as well. And I also serve as the volunteer chairman of the ASEA Science Advisory Council. The world of redox biochemistry is an exploding field of science. There are textbooks, medical journals, conferences that can be attended. This is a huge area of science, and the reason for this explosion has to do with the fact that it applies to all areas of biology. Redox signaling technology is really destined to fuel some of the greatest advances in medical science this century. It's fundamental to all biological multicellular processes, plants, animals, bacteria. It's non-specific, non-toxic, and applicable to a broad range of processes and pathways in all kinds of physiology. It's at the very core of mediating and regulating mechanisms that restore functionality and health to cells. So, how do our cells work, and how does this new science apply to understanding cells better? Here's a cross-section of a human cell, and as you can see, it's an intricate combination of machines and machinery that serves to help to hold together and operate this basic building block of our body. Cells have these machines that help the cell defend itself and replace itself and regulate itself. But there are three main areas of cell physiology where redox chemistry comes into play. The signaling equipment involves our antioxidants. These are complicated molecules that help defend ourselves from toxins, eliminate free radicals, and help shield against a variety of threats. Additionally, there are membrane transport systems on our cell membrane. We can call them a mailbox, that help allow for the infusion of oxygen and food and the release of waste products and metabolites. Additionally, cells need to signal one another. There's a complex and intricate system of communication. We can call it cell phones. And this communication allows for cells to communicate their status to one another, and send emergency messages to call out for help from the immune system, for example. Communication is critical to the health and life of a cell. So redox signaling molecules activate the effectiveness of our antioxidants and upregulate their production. Redox signaling molecules lubricate these channels of input and output through the cell wall and improve the efficiency of travel of these materials. And redox signaling molecules improve the capacity of the communication systems for cells so that they're working at optimal levels and there's no dropped calls or bad messages. So, healthy cells lead to healthy tissue, which leads to overall health. And so we can extrapolate this to the whole body. Health is equivalent to healing for a variety of reasons. Our cells are damaged every day. So there has to be a way to handle and deal with that damage, whether it be chemicals or infections or ultraviolet damage. This happens every day, all the time. Additionally, we have injuries, minor injuries, cuts and scrapes, damage millions of cells, and they have to be repaired or replaced. Additionally, we also see that exercise and exertion can damage cells. That's where that achy tenderness comes from. So cellular healing is equivalent to health. And without the cellular healing process, we would not be able to live. In fact, if our body failed to be able to manufacture any of these little redox signaling molecules, we would be dead within hours. Healing is at the very heart of our health, and all health problems, any disease you can think of, is linked to damaged cells. So where do these little redox molecules come from? Well, they come from within every single cell. Our cells have, in our machinery, we have little tiny mitochondria. These are structures that produce energy. So a cell takes in food and it converts food into ATP through the Krebs cycle, that process of oxidative phosphorylation. As a side product of the production of energy, redox signaling molecules are generated. Now there's two kinds. One have a positive charge, one have a negative charge. The negative charge is called a reduced species. The positive charge is called a reactive oxygen species. So these are produced in every cell. Some cells have thousands of mitochondria, some have just a few. When they're produced, if there is an over amount or an imbalance in some way, glutathione has a way of breaking down these excess molecules to allow for the maintenance of homeostasis. And of course, glutathione is primarily located near the nucleus, a very important protected area of our cell. So in a healthy cell, you can see that we have homeostasis, a balance of these two different kinds of redox molecules. And as a result, we've got everything working in a physiologic balance. In a damaged cell, redox signaling messengers are out of balance. And here you're seeing evidence of oxidative stress that's occurred, and there's an abundance of the red triangles, the reactive oxygen species. These are leading to damage to the cell membrane, which is very critical, as well as to the nucleus, which could cause a complete breakdown in the cell function. And so this damage needs to be contended with. So in healthy tissue, redox signaling is in homeostatic balance. We now got a multitude of cells that are now in balance. Where there's oxidative stress, this would signal a repair, replace, or protection process. And so there's a burst, perhaps from an injury or an infection, and this is signaling trouble. So the cell group of tissues here have to decide what they're going to do about it. That particular cell decided to replace itself, and a neighboring cell comes in and fills in the gap to promote better health for the tissue. In the last 10 years, there's been some astonishing findings in this field of redox signaling. This fundamental cellular process is involved in every single form of life. And many of the mechanisms involved for life and maintaining life involve redox signaling. And so some of those are listed here, from cell division rates to tissue regeneration to vascular regeneration, inflammation, antimicrobial defenses, leukocyte adhesion. All of these involve redox signaling biochemistry. This list is growing and expanding exponentially. And today, there are well over 100 original scientific articles from scientific studies that are published newly every single month. It's an incredibly fast-growing field of science. So, what about chronic oxidative stress? This would be the advancing of aging in our tissue or poor health. So here we've got a multitude of oxidative stress signals, and this is a situation where there's a persistence and an inability for the cell to correct itself. This would lead to poor health. But what if we could infuse somehow a balanced resource of these little molecules into the tissue? What would be the implications? And look at the balance that we would create, the resources that the cell could then make use of. What would this lead to? We'll come back to that in just a second. So stable redox signaling compounds are central to healing mechanisms, whether it be damage control, protection, repair, communication, replacement. Every fluid, intracellular and extracellular fluid, is full and completely inundated with these particular little healing molecules. So to review, the steps to cellular healing involve damage recognition, detection and elimination of threats, and cellular repair or replacement. So here's a electron micrograph that has a fluorescent stain. It helps us look more clearly at the way cells flag themselves. This is a cell that's full of oxidative stress, This excess oxidants alerts the cell that damage has taken place, and the immune system responds to this oxidative stress. And so here are those red flags, and in this situation, the immune system comes in, deploys its weapons to take care of the malfunction of the virus or germ. Then, once the threat is eliminated, there's no longer a need for that presence of the immune system, so it retreats, and then through the process of normal cell division, this replacement process fills in the missing holes, and we restore homeostasis to this tissue. So let's talk about some discoveries. The question posed earlier, what would happen if we could manufacture a stable complex of redox signaling molecules? Could we determine their bioactivity? Could it be proven non-toxic and readily absorbed? Could this product or source be commercialized? And the answer to these is yes, and let me explain about that. After approximately 17 years of foundational research, a complex of redox signaling molecules was created that had a stability that was no longer than about 10 minutes. This created limits for its ability to be applied to biological processes. And through the work of Dr. Gary Samuelson and his team of scientists, a methodology to stabilize this solution of balanced redox molecules was developed. The process that they employ, it includes this. There's a formulation that comes from pure salt and distilled water. That saline solution travels through a patented 3-day electrolysis process that allows for the development of this collection of 16 different redox molecules, virtually free of salt. There are 8 oxidants and 8 reductants that are created, and this product has an extremely long shelf life. The shelf life is a year. The half-life is about 2 years. There's a tiny amount of sodium that persists in the product, and it's there to produce an electrical stability. It's 123 milligrams in 4 ounces, which is a very tiny amount. It's equivalent to the amount of sodium you would find in a half a slice of whole wheat bread, a drop in the bucket. One of the first steps in determining whether or not this would be a safe and non-toxic substance for consumption is to do some studies. And so in vitro studies were done on human cells. This was performed in 2009. What they did is they took, in tissue culture, exposed human cells to various concentrations of ASEA and a positive control substance. And the way this was studied is based on knowledge that certain transcription factors are translocated or moved toward the nucleus when they are exposed to toxins. So transcription factors like the P65 unit of NF-kappa B and P-Jun were studied. And with varying concentrations of ASEA, you can see that the nucleus of these cells didn't change anything beyond the control, the negative control. This is quite astonishing that there was absolutely no evidence of toxicity at amounts and concentrations that would be 10 to 20 times what we could consume orally. So the safety was unprecedented. In fact, in the entire research profile of this product, there's never been any evidence that there is any lethal dose. No median lethal dose was ever discovered. Now, additional in vitro studies were done in 2009 at the Pacific Northwest National Lab. And in this, there were 2 components to this particular research protocol. The first was to determine if there was a change in the capacity or the effectiveness of glutathione and SOD, superoxide dismutase, and their ability to protect some human cells, endothelial cells, from damage from a toxin. So using an array design stress gen kit, human cells were exposed to known toxins. And then the effectiveness in them being able to protect themselves was measured. And the cells exposed to ASEA showed an improvement in the capacity or function of glutathione and superoxide dismutase to protect themselves in the order of 500%. This is unprecedented, never been seen before, and that by itself was amazing. But in addition, it was determined that there was also an upregulation in the production of these powerful antioxidants. So here, the pictures show this. Using a standard Western blot analysis, cells exposed to ASEA activated the nucleus to call for an increased production of these antioxidants. This was measured by looking at transcription factors like NRF2 and DAPI. These were dramatically affected, and there was dramatic movement toward the nucleus, indicating increasing in production. This effect lasted for more than 2 hours and was quite astonishing. But way beyond that was the next finding, and that was that there was no normal provocation of this normal inflammatory transcription factor, NF-kappa B, despite invoking the transcription factor NRF2, which increased antioxidant production. In other words, the normal mild inflammatory response that comes from the upregulation of antioxidants did not happen. And this has not been seen before in the scientific world, and raised a lot of eyebrows thinking, this is different. This is not what we're used to seeing. And that, of course, underscores the fact that ASEA is not a nutritional product like you mostly see out there. This is a product that is native to the body. It's what we naturally produce in our body, but as we age, of course, we produce less. And as we have fewer mitochondria per cell as we age and see a decline in our mitochondrial populations as well as our mitochondrial efficiencies, we see a downticking in our capacity to do repair work. This is what we're seeing is an infusion of these little molecules has a way of kind of changing that natural decline. Athletic performance. Athletes who started drinking ASEA began contacting the company and saying, you know, I'm seeing a tremendous improvement in my performance and recovery, and the research, that profile that had been developed over many years had nothing centered around exercise physiology. So exercise physiology is foundational to health. We're all athletes at some level or another, and we all are seeking improvement in our performance and our ability to have endurance and recovery. So we wanted to do double-blind crossover placebo studies, the gold standard of science. And in looking around the world, probably the top 10 most recognized scientist in the area of exercise physiology was Dr. David Neiman. Dr. Neiman is a full professor of health and exercise science at Appalachian State University. He has written over 200 peer-reviewed publications. He's authored over 300 articles on health and fitness. He's written 9 books. He's currently vice president of the American College of Sports Medicine. He's also an athlete himself and has competed in over 58 marathons and ultramarathons with times of elite runners. His times of under 3 hours is truly an accomplishment of itself. He leads the metabolomics lab at the Human Performance Lab in this prestigious North Carolina research campus. There, he has studied for many years now the connection between nutrition and performance. Depicted here is a group of scientists, his PhD team, and the world's largest shielded nuclear magnetic resonance machine. This machine was instrumental in proving beyond any shadow of doubt that there actually are stabilized redox signaling molecules in ASEA. This was crucial and foundational in developing a hypothesis as without any shadow of doubt that there really have to be these molecules in order to know how to develop our ongoing research. As you propose a theorem, it must be proven or disproven. And This discovery, which is outlined in this particular graph, shows that these two peaks are clearly evidence of these molecules, and including superoxide, I might add. And this is the first time in the history of modern world that it was defined using NMR technology that there really are stabilized reaction oxygen and reduced species in our product. The metabolomics, the study of the fingerprint of our metabolites from metabolism of our body, is a new and emerging science that only 5 years ago was the very beginning of our ability to actually measure these very, very specific components of burning fuel. As we burn fuel, each of us leaves a fingerprint behind, kind of like the exhaust of combustion, and it leaves an imprint of what we've actually consumed and how we've consumed it. So ASEA conceived a double-blind crossover placebo study with Dr. Niemann, and his team postulated that if they gave a group of athletes 4 ounces of ASEA a day and divided them in 2 groups, of course they wouldn't know who's in which group and which group was getting the placebo and active product. Test their blood, then have them do a cycling trial, and then look at their blood again. We were just really curious as to what would actually take place. So using very, very specific ultra-sensitive mass spectrometry, this study demonstrated a huge shift in 43 of 108 metabolites. In this graph here, you're seeing the blue dots would be the placebo group, and the red dots being the active or ASEA group. And as each athlete was crossed over, they then created a new imprint or a collection of metabolites that gives you that dot. And so before exercise, every athlete, within a week now, just a 1 week period of time, each athlete had a tremendous shift in over 1/3 of their metabolites. This caught the entire scientific team by surprise. They questioned the statistics and they double-checked them. And so what was discovered was that before exercise, there was a huge shift in primarily the fatty acids in our blood. Now, fatty acids are a source of fuel. This is not the same as cholesterol or triglycerides. These little fatty acid molecules are crucial fuel for life and for exercise. Things like palmitic acid and myristic acid are used for fuel, and they're very vital to our physiology. This big shift or mobilization of fatty acids for fuel was postulated for why there was a big improvement in endurance. And we believe that there's an advantage in mobilization of fatty acids, as they're about 6 times more valuable for a source of fuel than glycogen or sugars. We oxidize fatty acids for energy. And all of these were done without any evidence of injury to kidney function or liver function. So it led the way for the need for further studies. So profound impact on our mobilization of fatty acids as they help in cellular respiration. And this is a foundational shift in our metabolic fingerprint that they've never seen before. Pharmacokinetics has to do with the way in which this happens over time. So the next study that Dr. Niemann's group embarked on was using gas chromatography and mass spectrometry to look at the way in which 12 subjects who were randomized to either get placebo or ASEA to watch how their metabolome or their metabolic shift was occurring in a time period. So in looking very quickly, after just 30 minutes of ingesting 4 ounces of ASEA, there was already a defined distinction in the group, the placebo group or the active group. And here, you're seeing a real distinction, even 24 hours after a single dose of ASEA. So in looking at this spectrum over time, you can see that different metabolites are being expressed. In other words, the fingerprint was different at each level of time. And this all has led to postulation as to what this will lead to in terms of human performance and physiology and maintaining homeostasis in our tissues. And another trial was done in 2012 to look at endurance. Here we asked mice to get on a treadmill and after consuming ASEA and watch how they perform. And after 7 days of being given ASEA, we were theorizing that in the same way that humans had a mobilization of fatty acids, there might be an improvement in endurance. The mechanism would be through sparing the use of glycogen in the muscles and improving endurance in that regard. So in this instance, 30 mice were divided into 2 groups, double-blinded, and then a washout and a crossover to do real science here. So here are the findings. After running on a treadmill to exhaustion, mice given ASEA showed a 29% better endurance than the placebo group. And this was an extremely excellent p-score of 0.0000572. Unequivocal difference. Additionally, after doing muscle biopsies, they determined that there was sparing of glycogen, in other words, a reduction in muscle glycogen usage by 33%. When we don't burn our glycogen, we have better endurance, more stamina, and easier recovery. Additionally, there was preliminary evidence that there was some mitochondrial biogenesis as well. What we can conclude here is that ASEA and redox signaling formulations can have tremendous anti-aging benefits. Aging really occurs due to the proliferation of damaged or less efficient cells that push away or gradually replace efficient cells. These less efficient cells accelerate aging and promote more damage. These damaged cells have the ability to repair themselves, but they're not given clear action eliciting signals to do so. And so they go on and replicate their mediocre state. And this leads to tissue decline and decline in the organism. Redox formulations have anti-aging benefits by increasing the production and efficiency of our endogenous or internal antioxidants like glutathione and superoxide dismutase. And this protects us against oxidative stress. Superoxide dismutase is involved in neuronal health in particular and protection of our nerve health. The detoxification process is all mediated through these powerful antioxidants. And of course, reductants, these negatively charged species, are necessary for the regeneration of antioxidants in our cells. Anti-aging benefits are also seen when we notice that there's quicker detection of cell damage, quicker replacement of damaged cells, a more precise immune response, an activation of a proper redox potential that optimizes signaling and communication in our cells. So, why is a healthy balance of redox messengers important? Too many oxidants in the cells or blood causes damage and aging to all tissues. This would be someone who might be burning a lot of fuel with exercise and created a lot of oxidative stress, and if this isn't corrected and recovery allowed, it would lead to an environment where there's a lot of rust and a lot of breakdown. The incorrect balance of reductants and oxidants can cause the immune system to attack healthy cells and inflame tissues and lead to slow healing, or even worse, system problems where the body is attacking itself, auto-attacking. Too few antioxidants will allow for damage, and infected cells that should be destroyed and so forth, but these infected cells would thrive or divide and spread and cause damage, and this is creating havoc in our tissues. We can maintain a healthy redox balance by doing a few simple things. We want to have a diet that supports the immune system by eating raw and green vegetables, juices, and herbs, perhaps some vitamin supplements. Find a product like ASEA that has a correct balance of of redox signaling molecules to fuel our immune system and maintain a positive attitude. Our thoughts really do measurably affect the health of our body. And there's probably no more powerful force in our life than the way we think. Redox signaling molecules can promote healthy cells and allow for restoration of cells. There are anti-aging benefits. There is a preservation of healthy cells. We empower cellular protection. We see endurance and athletic recovery, antioxidant empowerment. We build cell defense. We optimize our immune function. We speed restoration of healthy tissue, essentially, quietly, and foundationally powering up our health. I appreciate your attention and welcome your questions. And I encourage you to explore completely the science behind this revolutionary product that is for the first time applying this new science of redox signaling. Thank you very much.